Finally, the panels array I just ordered is ready. Now, how do I get the maximum efficiency of my panels?
Well, you could add an MPPT to your system.
What is an MPPT? And most importantly, what is an MPPT for?
Well, an MPPT is an electronic device, so you can track the maximum power point of your system. Now, there are two techniques. The first one is the indirect one. So you use the voltage open circuit of your panel and your current in short circuit of your panel. The other one is the direct one. You subtract the voltage and the current direct from your panel. And now, these methods are perturbate and observe and incremental conductance.
Here we have the most graphic explanation of what the algorithm of this method does. Here we can observe the power curve with respect to voltage. Here we found the MPP, where is a power of MPP and a voltage of MPP. The first thing the algorithm does is establish an initial voltage, V1, where it also opens an initial power, P1, and then increase the voltage for a difference of voltage, which generates another power point, V2 and P2. What the algorithm asks now is the current power greater than the previous one? If so, then it continues increasing the voltage. For example here, V3 and P3. At a point after the MPP, the power will be lower than the previous one. For example here. So, the algorithm will change the direction in which the voltage travels, causing it to begin oscillating near the MPP. Here, the voltage decrease and the power change to this point. Again, the voltage decrease, but now the algorithm asks the same question and change the direction. Now the voltage increase again and oscillating from this point.
Now, the incremental conductancy method. This method has the relation with the conductancy and a derivative of the power voltage function. Now, this derivative works as dp dv, which could be evaluated as three factors: dp dv greater than 0, which means the voltage is scaling to get to the maximum power point. Now, dp dv equals to 0, which is the maximum power point, and dp dv lesser than 0. These are the three cases which you will analyze this method. Now, the conductancy just make this more certain, because you do this exact same method, dp dv, but you evaluate it respect and the conductancy, which instant conductancy, which is this. Now this equals to 0, and this is the same representation as what you draw in this curve. Well, now we're going to explain the MPPT methods by its graphics. So, as you can see, it in this is the PYO method, or the perturb and observate. You can see that it tries to get to the maximum power point, and when it gets, like right here, it still oscillates. so it doesn't get an oscillator at big steps. This is the big differences in the PYO and the increases conductance. So it's the steps. Now we're gonna see how the incremental conductance sees. This is the graphic of the incremental conductances. So as you can see, the steps are so small you can't even differentiate between the maximum power and the MPPT working. But if you go further, you're gonna see the little steps it has. So the differences are minimum. Now, both of these graphics have an steps, so it's try to simulate a cloud coming by. So that's why it have this particular form and drops the power value in both of this.